mathematicians, we were looking at many algebra problems. So we'll do some real analysis problem also. So this is a problem from sequence of functions. So everybody might think that the problems asked in sequence of functions is a little trickier, but in if you look at the previous year questions, if you know some limit, if you have some basic understanding of sequence of functions and the series of functions, then you can answer all of those problems. So we will cover those problems also in the upcoming videos. Okay, let's see this problem. So it is a part B problem, and so fn of x is defined to be x power 1 by n, and it's defined on close 0 comma 1. The options are limit n tend to infinity fn of x exists for all x belongs to close 0 comma 1. That means that you fix a x belongs to close 0 comma 1 and you fix it that x here, then you put limit n tend to infinity. That is, now since you have put a value for x, some fixed number, say 1 by 2, then we'll get 1 by 2 whole power 1 by n. Then you look at limit n tend to infinity 1 by 2 whole power 1 by n. So that is what we define it to be f of 1 by 2. Okay. So what I am saying is, you fix alpha belongs to close 0 comma 1. Then you look at mn of alpha. What you will get? You get alpha power 1 by n. Okay. Now if you look at alpha power 1 by n, it is a number sequence. So for n equal to 1, you get a number. For n equal to 2, you get a number. So for varying n, you will get a number sequence. So you can talk about this sequence, limit n tend to infinity mn of alpha. So basically it means that the limit of the sequence alpha power 1 by n. What is the value of limit n tend to infinity alpha power 1 by n? If this limit exists for every alpha here, then we say that limit fn of x, limit n tend to infinity fn of x exists for all x belongs to close 0 comma 1. Okay. So and this limit value is what we denoted by f of alpha. Okay. So I hope you understand what this is, what is called this function. For each alpha belongs to close 0 comma 1, we have defined f of alpha. So this defines a function, again a function from close 0 comma 1 to r. Okay. So if fn of x is a sequence of continuous function from, fn of x is a sequence of function from close 0 comma 1 to r, then its limit function also close 0 comma 1 to r. Let me explain it one more time how to find this function f. So f is a function from close 0 comma 1 to r. We want to understand what is f of alpha. So f is defined on close 0 comma 1 means this you take a alpha from close 0 comma 1. Okay, then you look at fn of alpha. Okay, fn of alpha will be a number sequence. Why it is a number sequence? For each choice of n, for n equal to 1 you will get a number, for n equal to 2 you will get a number. So this will give me alpha power 1 by 1, alpha power 1 by 2, alpha power 1 by 3, alpha power 1 by 4. That is a number sequence. Now you look at the limit of that sequence. Okay, so the limit of this sequence exist, may not exist. If it exists, then we define that value to be f of alpha. Okay, now if this sequence converges for all alpha here, okay, that means that this function f can be defined for all the points in the close 0 comma 1. We say that limit n tend to infinity fn of x exists for all x belongs to close 0 comma 1. So we will see one example. uh, okay, so in this problem it is given that fn of x from close 0 comma 1 to r, fn of x equal to x power 1 by n. So we fix alpha belongs to close 0 comma 1. If alpha equal to 0, then what will you get? Then fn of 0 equal to 0, because if you put 0 you get 0 power 1 by n, 0 power 1 by n is 0. Okay, so then 0 power 1 by n equal to 0 for all n. Therefore f of 0 is, what is f of 0? F of 0 is nothing but limit n tend to infinity fn of 0. Okay, so what is limit n to infinity fn of 0? That will be first you have to take 0 power 1 by 1, 0 power 1 by 2, 0 power 1 by 3. So basically this is f1 of 0, this is f2 of 0, this is f3 of 0, etc, etc, but all these numbers are 0. Okay, so when you let a limit enter to infinity in this sequence, you will get 0. So we get limit enter to infinity fn of 0 equal to 0. So that value is what we define it to be f of 0. Okay, so if the limit of this sequence is what we define it to be f of 0. Okay, so we get f of 0 equal to 0. Now let we take alpha belongs to closed 0 open 1. Then you take if you if alpha is positive, then alpha power 1 by n converges to 1. Okay, so that is a result from uh, our sequence and series, first course in sequence and series. So whenever alpha is positive, we get limit n tend to infinity alpha power 1 by n converges to 1. Okay, therefore f of alpha, what is f of alpha by definition? In the sequence, you are in the sequence fn of x, in place of x you have to substitute alpha, then you have to let n tends to infinity. So basically what will you get? You get alpha power first 1 by 1, alpha power 1 by 2, alpha power 1 by 3. So this sequence you will get, then limit of this sequence. So this sequence is nothing but uh, sequence f1 of alpha. Okay, so n equal to 1 to infinity. So this is the sequence. This is the sequence. These two sequences are same, and so this sequence is nothing but alpha power 1 by n sequence. Okay, so since alpha is positive, this sequence alpha power 1 by n converges to 1. Okay, so we get f of alpha equal to 1 for all alpha belongs to open 0 close to 1. So the pointwise limit function is f of x equal to 0 if x equal to 0, 1 if x belongs to close open 0 close to 1. Okay, so just a simple fact, we want to find f of x in every point of close 0 comma 1. Okay, so you fix a point in close 0 comma 1 and you fix that number here and you let n tend to infinity. So whatever the limit sequence you get, that is your f of alpha. Okay, if that this function f of x can be find for all the points in close 0 comma 1, we say that point-wise limit is exist. Okay, so first option is true. Let's see the other options. So second saying that, so basically this limit tend to infinity fn of x is nothing but f of x. Okay, why? That is how f of x is defined. So you fix a x, then you let limit enter to infinity, what will you get? You will get f of x. That is the definition of f of x. Okay, so they are saying that f of x exists for all x belongs to closed 0 comma 1. That is the first option that we verified. Now they are saying that f of x defines a continuous function on closed 0 comma 1. So if you look at the f of x, it is 0 at 0 and 1 in open 0 closed 1. So how the graph of this function looks like? So it is easy to draw the graph. So at 0 the function is 0. So say this is our 1 and everywhere else it is 1. Okay. So in open 0 closed 1 it is constant function 1. Only at 0 it is 0. So clearly we can see that it is a this function has a jump discontinuity at 0. Okay, so the function jumps when you move right of 0. So this function is clearly not continuous at 0. So other way of seeing it as why it is not continuous at 0, you can explicitly construct two sequences. So you consider the sequence 1 by n, consider the sequence 1 by n that converges to 0. Now you find the f of 1 by n. Okay, f of 1 by n. Now 1 by n is positive for all 1 by n belongs to open 0 close to 1. So for every x belongs to this number, this interval, f of x is 1. So we get f of 1 by n equal to 1 for all n. Okay. Therefore, since this sequence is 1 for all n, this sequence f of 1 by n converges to 1. It is a constant sequence 1. Okay. So 1 by n converges to 0, but f of 1 by n converges to 1. Now, if f is continuous at x, then whenever xn converges to x, f of xn should converges to f of x. Now you take, we are looking at the continuity at the point 0. So we take a sequence 1 by n converges to 0, and we get a f of 1 by n should converges to f of 0, right? So, but what is f of 0? F of 0 is 0. You see, f of 0 is 0, but so since f of 0 is 0, this f of 1 by n sequence should converges to 0 if f is continuous at 0. But f of 1 by n converges to 1, which is not equal to f of 0. Therefore, f is not continuous at 0. Okay, so therefore f of x is not a continuous function. They are saying, third option, they are saying that fn converges uniformly on close 0, comma 1. Now, very important result in the sequence of functions. This each fn is a continuous function. Okay, fn of x equal to x power 1 by n is a continuous function for a fixed n. If you put n equal to 1, you get x. If you put 1 by 2, you get f of x, f2 of x will be x, root x. Then x power 1 by 3. All these functions are continuous here. Okay, so it is a sequence of continuous function, and its converges, suppose it converges uniformly here, then the limit function also has to be continuous. So here, uniform limit of a sequence of continuous function is also continuous. Okay, or if a sequence of continuous function converges uniformly to a function f, then the limit function f also has to be continuous. But we just saw that our limit function f is not continuous, therefore the convergence is not uniform. Because if the convergence is uniform, then this function has to be continuous, but this function is not continuous. Therefore, this option is wrong. And fourth option, they are saying that f of x equal to 0 for all x. The limit function is identically 0, but that is also not true, because we saw that this is the limit function. Clearly, this is not identically 0. Okay, so yeah, it is a very simple problem. In this simple problem, we covered some basic things about the sequence of functions and its point-wise continuity. We do more problem on sequence of functions. Okay, if you like the video, please like the video and subscribe to my channel if you haven't done it so far, and please share with your friends and your discussion groups. Okay, thank you guys, take care.